So we're going to continue our discussion of arrays. This is the program that we were working on last time. Hopefully you can think back and remember what we were doing. We read a bunch of numbers. We found the smallest item in the list, and then we printed out the list except for that item. So there's one more thing that I want to work on a little bit on this program here, and that has to do with our reading of the numbers. Someone from online has a question about the homework. You want to go ahead and type those in? I can stop for a second and answer questions about the homework. Why don't I'm going to just stop here for a second because we've got some questions about the homework. I guess I skipped that part today. So I'm going to just kind of shoot off in a different direction here for a few minutes, and then we'll come back and finish talking about this smallest program. So the question from online is, if I use a variable equal to the value returned by a function more than once, is it still better to use the function call itself instead of using a variable? Oh, I just realized you guys can't see that. Sorry. So the question is, if I use a variable equal to the value returned by a function more than once, is it still better to use the function call itself instead of using a variable? Does that make sense to you guys, or did you get lost? So you've got a value returning function, and right here in my program, in main, instead of calling find smallest and assigning it to a variable, and then putting that variable here in the argument list, I said, well, that's just a wasted step. I'll just put the call to the value returning function right here in the argument list. The question is, well, what if I'm going to use that value more than once? What if I'm going to use it 3 or 4 times? I would say, in that case, I would probably assign it to a variable first and then use that variable. Because otherwise you're going to end up calling a function multiple times, and that's kind of ugly, right? Does that make sense to everyone, what we're talking about here? So if I was going to print out the list, and then after printing out the list, I was going to have a CL statement that said the smallest number in the list was blank, I wouldn't want to do it this way, because that would mean I would have to call the find smallest function again. Instead, I would assign it to a variable, something like smallest gets find smallest. Right? And so then I could use this variable over and over again without having to call the function again. Any questions about that?
Why is it better to use that variable again rather than
call the function? Because every time you call the function, the biggest thing is that's inefficient, right? Every time you call the function, it takes up more processor time, right? So it's slowing your program down. Anytime you can avoid calling a function is probably a good idea to do that, because that's fairly time intensive. Not that we would be able to tell in this program the difference, but just as a matter of good practice. Okay? Go ahead.
My question was about the documentation for classes.
Okay.
You wanted us to have pre and post conditions for all of our public member functions.
Okay, so in the fraction assignment, I want you to have pre and post conditions for all of the public member functions. Okay, sorry, I'm just repeating. Go ahead.
I was sort of wondering how you wanted us to present that.
So, okay, so how do I want you to present that so it's readable? Yeah, I haven't shown you any examples, and I'll say that on this this first time that you're going to be doing this, documentation on classes, I'm not going to be very picky. I just want to see that you're giving it your best shot. We could go ahead and look for a moment at, hold on, the style convention for that. Yeah, that's okay. I did answer it, but that's okay. Let's see. What was I doing? Style convention. If you look at style convention 1D, that's what we're talking about here. The header file should begin with a typically very large header comment. This comment should include a general description of the class, followed by a listing of all the prototypes of public members, each with pre and post conditions. So this is the main part. Right here, followed by a listing of all the prototypes of public members, each with pre and post conditions. So basically what that means is you've got your class declaration. You're going to go copy each prototype from the public section, paste it up above so it's a comment, and then underneath it you're going to say preconditions colon something, postcondition colon something, and then leave a little blank space and then put the next prototype, and underneath that the same thing, precondition, postcondition. I haven't said what precondition, postcondition is yet, but does the format pretty much make sense? Okay. So a postcondition is basically kind of a formal way of saying what is going to be true when this function is done executing. Okay, and if you think about it formally, basically what that means is you have to say if there's going to be any output and if what's going to happen to any reference parameters or what's the return value going to be. Those are basically the only three things that can happen, right? The only three things a function can do that affect anything outside of itself is output, reference parameters, return value. Or if it does something to the member function, I guess. The calling object. If it does something to the calling object, you'd want to say that in the postcondition. Okay? So, postcondition is what's going to be true when this function is done. So you might say something like, returns the sum of the calling object and the parameter of their fraction. Does that make sense? So I've actually referred to the parameter by name, so there's no question about what I'm talking about, and I've described exactly what the function produces. The precondition is what has to be true before this function starts executing in order for that postcondition to hold. So is there anything are there any limitations on when the postcondition is going to work out right? Okay. In this class, there really aren't going to be, there may not be any preconditions at all, because all the functions basically work no matter what. But for example, in the dividing member function, you might say something about the value of the parameter can't be 0, right? So that would be a precondition. Okay, that's kind of a stretch, right? I'm trying to, hard to think of what might. Right. If one of the arguments had a certain range, that would be a good precondition. Often if there's input going on in the function, you'll say something like a precondition is that the stream is ready for reading, and the next thing in the input stream is in this format. Yeah, right. Okay, because otherwise the function won't work. You don't have to say things like there is a fraction object has been declared, right? because a lot of times people are trying to think, okay, what can I think of to say as a precondition, right? You don't have to say that because you can tell by looking at the prototype, right? There's going to be a fraction parameter, so you don't have to say that in your precondition. Okay, so basically what this is just a very formal way of informing a person using your class what the function does and what the requirements are. Okay? Don't spend hours and hours on this part for this assignment, for the fraction assignment. You know, give yourself half an hour, start your stopwatch, and if you're still working on it after half an hour, quit. Okay. All right. Any other questions before I dive back into the program we were talking about? Oh, you want to Okay, so there's another question from online. In one of my for loops, I have a constant 2. Should I make it a named constant? Which file would I put it in? My guess is that in your for loop, that constant 2 isn't really representing anything significant. Like, it would probably be hard to think of an appropriate name for that constant. It would be really helpful, and it would tell a person reading your program why you used the number 2 there. So my guess is you probably want to just leave it as the literal 2. Which file would you put it in? You know, that's actually a good question. I haven't talked about if you have a constant in a class that you want to be available to the whole class. And that's actually not something that we're going to cover in this class. We will cover that in like an advanced C++ class. Basically, you would declare the constant in your class declaration, but you'd also have to use the keyword static in front. So it's complicated. Yeah. Okay, so since I have this big, huge header file at the top of my, since I have this big, huge initial file comment at the top of my header file that lists all the pre and post conditions of every function, do I still need comments next to each function definition? And the answer is basically no. The only time in your implementation file that you would want to have comments, function comments, would be if it's a private function, so that, which means that you wouldn't have commented it in the header file, or if you want to say something, if it's a complicated algorithm inside the function and you want to say something about how the function works, something about the implementation of the function. Okay, so in my solution to the fraction project, I only have a comment next to one function, and that's my reduce function. Any other questions? Okay. So do you realize that every class, this whole semester, at the beginning of class, I've asked, are there any questions about the assignment or about the lesson? And every time, there have been none. And then today, of course, I forgot to ask, and there was like 4. Okay. Just, you know, Murphy's Law, I guess. Or something. Okay. So back to this program. I said that there's one thing that I want to work on a little bit that I'm dissatisfied with. It has to do with the read numbers function. And it has to do with a potential problem that could come up in the execution while this program is executing. And I want you to take a look for a minute, and before I tell you, just see if you can think of what the thing might be that I'm worried about here. What could go wrong when this function's executing? No guesses, huh? This is the kind of thing that, you know, if you're going to be doing programming In the real world, you want to be able to think of any possible situation that could make your program break, right? And I can think of a situation that could come up that would make this function break. Other than the obvious, which is if someone, was supposed to enter a number and they entered a letter or something. Okay, we're not going to go there. So, what if what if I have, let's see, how big was the array? 1,000. Okay, so what if I need to enter 1,200 numbers? What would happen? Bad things. Would the loop stop? Let's take a look. Okay, what's going to happen here? So if I say list, so the last item in my list has an index of 999 right now, right? There's 1,000 elements, so the last element has an index of 999. So let's say count is 999. I put the number in, no problem. I increment count to 1,000. I enter another number. I go back up here. Number is still greater than or equal to 0, so I say list sub 1,000 gets number. What's going to happen when I say list sub 1,000 gets whatever the user just entered? In an ideal world, I guess this is sort of my opinion, but in an ideal world, the program would stop and it would say that index doesn't exist in this array, right? What actually happens is C++ doesn't check that, and it just blindly sort of tries to do what you told it to do. Okay? Which means that the results are unpredictable. Sometimes it might actually work. Even though that memory location hasn't been allocated, C++ will put the value there and it just works just fine, no problem. Okay? The next time you run it, that memory location might be reserved for some other purpose and you'll get a runtime error. It'll say unhandled exception or something like that. So your program will just bomb. Okay? So, I guess it's not all that important to know exactly what's going to happen. The point is you don't want to do that, right? So how are we going to fix that? So add a condition to our while loop. Say as long as what they entered is greater than or equal to 0, and count has to be less than array size, right? That makes sense? Remember, I think I said last time that we might actually use that constant again here. So now we see that there might actually be an advantage to having that constant up there. If we change the size of our array, we don't have to go hunting through our code to find all the places we need to change the 1,000 to something else. Okay, tell me what you think. Is the result of this new code going to be satisfactory? Someone tell me what's going to happen now when I enter that 1,001st number. Okay, so from the perspective of someone sitting at the computer terminal typing numbers in, what's going to happen? I type in the 1,000th number, I hit enter, it says enter a number, negative to quit, right? So I type in that 1,001st number, and then what happens? It just goes on and does the next thing, right? It ignores that number that I typed in, and it goes on and it prints the list of numbers except the smallest, right? So that's better, I think, right? That's better than bombing, or better than having some unpredictable result. But I think we could probably do better than that, because basically what happens is, first of all, the user doesn't understand why he had to stop entering data. And secondly, the user probably thinks that that last number that he or she typed in got put into the array or into the list. So, any suggestions? Yeah, so basically, let's take a look inside here. Hold on a sec. So basically, when we enter that 1,000th number, we say lists of 999 gets number, and then we say count plus plus, and so now count is equal to 1,000. Do we want to type that? No, because we don't want the user to enter another number, right? So right here we could say something like, if count less than array size, do this, right? Else, else what? How about this? Right, so after they enter the 1,000th number, instead of saying enter another number, we're just going to say the array is now full and move on. That work? Okay. Yeah.
What if there's already a whole bunch of numbers in the string that have more than 1,000?
Well, what we're having the user do here is enter one number at a time and hit enter. So if the user does enter two numbers, and the second one is the 1,001st number, that it's going to get ignored. But that's not really what we intended the user to do anyway. There's not much we can do about it. So shall we test this and see if it does the right thing? You want me to do that? Not really? No, there isn't. I know you guys, I have that look on my face, and so you're trying to figure out what I'm getting at, right? So I guess what I'm getting at is that it might be a little bit tedious for you to sit here and watch me test this and see if it works, right? Since I would have to enter 1,001 numbers to see if it does the right thing. So yeah, maybe we could just see what happens if I change the array size to 5. Whoops. Right, now we see why it's good to have that constant there, right? So, I'm going to enter 6, 9, 13, 7, 5. And then it says the array is now full and does the rest. Does that look okay? All right. I can't see anything. Uh-oh. Shoot. Sorry, guys. I suddenly realized that I'm not sharing my desktop. Ugh. Is that better? Probably something didn't feel quite right. Okay, so here's the code that I just was working on. I added this and count less than array size, and I added this if-else statement. Bummer. All right, so basically I'm done with this example, and I want to go do another example from scratch. Okay, so I think I still might want my read numbers function. So let me keep it. I definitely don't want my find smallest function. And yeah, I'm going to just get rid of that too. So for now, I'm going to do that. And So what I want to do now is write a function that reverses the contents of an array. Okay, just kind of basically I just picked some sort of a task that involves some sort of array processing, so that we can just kind of practice using arrays a little bit more. Let me also just make kind of a side comment, and that is that I'm kind of moving more into this thing where instead of saying write a program that does blank, I'm saying write a function that does blank. And so what that means is you write the function, and then I'll probably have to put that function in a program that tests it to see whether the function works or not, right? So that's why I'm going to have a read numbers function and a print list function. Those are going to be the functions that I'm just using to test to see if this function I'm writing works or not. Okay? So I want to write a function that reverses the contents of an array. So before we dive in, anybody want to try to just kind of in abstract terms tell me what the algorithm for this might look like? Okay.
For loops, that goes back. It starts at the number of items and then goes back and testing another array.
Okay, so you could have a second array. So you could introduce another array, and then you could have a for loop that starts at the end of the original array and goes through and just puts, so you'd have a counter going the opposite direction, starting at 0, and putting numbers from the original array into the new array. Yeah. Well, okay, so I think what you said was, you said something about creating the array and filling the array, and we don't actually have to do that because we're just writing a function that reverses the contents of an already existing array. Well, no. So the question was, the user's going to input the numbers, right? And the answer is, I want to be clear that I'm just talking about the function here. Right, so we're writing a function that doesn't really know where the numbers came from. It just knows that it's got this array, and it has to reverse the items in the array. So it's a good distinction. The suggestion that we had, I think, would work. We could create a new array, and then copy the elements from the old array into the new array in reverse order, right? So we basically have two counters going at the same time, one starting at the top, one starting at the bottom. Then when we were done doing that, we'd have one more step still, because we'd have to copy that new array back into the original array, right? Does that make sense? Because the job of this function is to reverse the contents of this array. If we just copy the contents of the array into a new array backwards, we haven't actually done anything to the original array, so we'd have to copy it back in. Okay, so the question is, could we do it without having this extra array? So if we just started at the end of the array and copied each number that we saw into the beginning of the array, so we had counters going in opposite directions, would that work? They will. Yeah, they would collide, right? It would work for the first half of the array, but then when you got to the halfway point, you'd be copying the stuff that you'd already copied into the front half of the array back into the second half of the array. So does it have to be two arrays? Persistent. I can think of a way to do it just using one array. Sorry? In a variable. And a variable, yeah. Right, so we know how many items are in the array. The way I would say it is let's take the array, and let's have a counter that starts at the end, And let's have a counter that starts at the beginning. And let's swap those two items. That makes sense? And then move the counter at the bottom of the array up and move the counter at the top of the array down. And then swap those two. And keep going. And then when the counters that started at the bottom and the counter that started at the top meet each other, you're done, right? Who needs me to? You want me to explain that again? Okay, I will. So I will explain that again, but taking a step back just for a second. Let me point out that we're doing an awful lot of thinking about this before we actually dive in and start writing code, right? So just don't be afraid to do that. Really think this through before you I mean, I haven't even talked about anything C++ at all, right? I've talked about array. So I haven't, this could be a Java class or a Visual Basic class, right? No code yet at all. We're just talking about an algorithm sort of abstractly. All right, I actually want to draw a picture of this. Yay, paint. If I can find it. Accessory, do this. Paint. Okay. Really, I just want to draw a picture because I think this is kind of fun using paint. And you guys have to watch. Okay, so shapes. I want one like this. Let's say this is my array. And okay, there we go. Almost as fast as just drawing it on the whiteboard. Those are my indexes. Oops. Okay. So if I have data in all of these cells, what I'm saying, and I want to reverse them, what I'm saying is, let's start with one counter equal to 0, and the other counter equal to 10. So, count 1. Actually, you know, I'm going to be more precise here. I'm going to call this more descriptive. I'm going to call this forward count. And I'm going to call this one backward count. So forward count starts at what? 0. Backward count starts at 10. Whoops. Or it would be array size, right? In our actual code, it might say backward count gets array size -1. Or actually, I'm not sure this will make sense yet or not, but actually, we're going to remember that we typically only use a part of the array. So it's actually not going to be array size -1. It's probably going to be num items -1. Anyway, if that didn't make sense, you'll see it in a minute. Okay? So we start off like that. We say swap list sub forward count and list sub backward count. So we swap these two, list sub 0 and list sub 10. And then we add one to forward count. That didn't work. And we subtract one from backward count. Right? And then we swap those two. Swap. Did anyone know what the sound was that I just heard? Oh, sorry. I thought it was me. So swap 1 and 9. Right? and then I add one to forward count and subtract one from backward count and swap those two. Everyone getting the picture now? So it's going to go 2 and 8 get swapped, and 3 and 7 get swapped, and 4 and 6 get swapped, and then I'm done, right? Okay. Let's think about how to actually put that into code now. So here's my void reverse list. And what am I going to need in order to reverse a list? What are the parameters going to be? I'm going to need the array, which I'm going to call list. I'm going to need the number of items, right? Okay, so remember I had a forward count, and what did it start off as? Okay, oops. And then I had a backward count, which started off at 10, which was num items minus 1, right? That makes sense. No, does the minus 1 make sense to everyone? The 10, in that picture I just showed you, the last item in the array had an index of 10, which means there were 11 items in the array, right? Okay, so no items minus 1. Okay, now, thank you. What kind of loop do you think we're going to want to have here? What's the condition on the loop going to be? When do we want the loop to stop? Okay, so in our example here, when we stopped is when forward count and backward count were equal, right? You're on the right track, but we need to think about what's going to happen if there's an even number of cells. They're never going to be equal, right? It would be like if there were 4 cells, forward count would start off at 0, backward count would be 3. And then we'd go down, forward count would get 1 and backward count would get 2, and we want to keep going. And then they would cross, right? Did you have a question? Okay. Close. But the forward count, as long as forward count is less than backward count, we want to keep going. Oh, that's what you were saying. Okay. Does that make sense? As long as forward count is less than backward count, we want to keep going. If they're equal, we're done. Or if forward count got to be bigger than backward count, we're done. So as long as we say forward count is less than backward count, okay? What do we want to do? Tell me don't tell me in detail. Tell me the general statement of what we want to do now. Swap which? Now tell me the detail. Swap what? List of forward count and list of backward count, right? Okay, as it turns out, in C++, there is a function swap. Okay, or you could write it yourself. If you wrote a function swap yourself, it would be 3 lines. Okay, you can't just say x gets y and y gets x, because when you say x gets y, the x that you had before got wiped out. So you have to store x in a temporary place and so on. But anyway, C++ will do that for you. I can say swap list sub forward count, comma, list sub backward count. That make sense? How does that look? We do have num item somewhere. You're absolutely right. We do need num item someplace. Okay, so we're not quite there yet. Yeah. Great question. If it's a void function and the list is not passed by reference, how does that change get back to the calling function? What's the deal with arrays and parameters? They're always automatically passed by reference. Right. Okay. Anything else not going to work here that you can see? I'm not going to tell you this time. You got to figure it out. No, we don't need to return anything. Yeah, right now forward count and backward count aren't changing, right? We got to update forward count and backward count. So what happens to forward count? Plus plus. And what happens to backward count? Okay. I think we're good, actually, at this point. So at least as far as this function goes. So let's make a prototype. And we're going to have to print the numbers. So real quick, I'm going to write a print list function. That look okay? Make a prototype for that. I think I'm ready to try it. I think it'll actually work if I do it, but there's something that we don't quite have right here in my function header. What am I missing from that? Think about pass by reference, pass by value. Everything kosher here? So this thing right here, right now, is passed by reference, right? Is that what we want? We don't want it to change, right? So what do we do, remember? You guys remember that? So the rule is if you've got an array that's a parameter, but you don't want it to change in the function, you put const, right? Okay. And I changed it there. That means I also need to change it in my parameter list. By the way, that's a very common source of errors that students have a hard time tracking down as you change your function header and then you forget to change the prototype. All right, I think I'm done. Let's give it a try. So I'm entering a bunch of numbers. Let's just go 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh wait, I'm supposed to just do one at a time. 1, 2, 3, 4, 5, 6. Whoa. Oh, that's right. The array size is 5. Yeah, did I not do well? Oh, because I didn't put my print list. Okay, yeah. My main function is missing the call to reverse list. and the call to print list. So you meant? Okay. And I want to change this to, let's say, well, 20. Doesn't matter. Actually, let's make it 1,000. Might as well, right? Take two. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9? What happened? I think I mistyped something. I have no idea what just happened. But let me try again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Huh! Same thing again. That's bizarre. Huh! Well, before we try figuring that out, let's at least see what happens if I don't type in that many numbers. And see if it works. So it should just be that in reverse. Okay, so it worked. Now someone tell me why it bombs when I enter that, what is it, 8th number? That is really random. Okay, I'm going to just ignore that, I think. Unless someone has an idea. Sure. So after I enter the 8th one, oh, no, sorry, never mind. All right. Well, we'll figure it out. I'm not going to spend a lot of time trying to work that out right now. If you remind me next time, I'll try to. I'll figure it out and tell you what's causing that. But I did want to say one more thing about this before we go. And that is that when I first wrote this function, I wrote it differently than this. And I think actually that this way of writing it is better. It's certainly more intuitive for students. But the way I wrote it the first time was I said, okay, can I figure out how many times this loop is going to iterate? If num items is 20, how many swaps am I going to have to do? 10. So I said, okay, I can figure out how many times this loop is going to iterate, so what kind of loop should it be? It should be a for loop. So I said, okay, for count gets 0, count less than num items divided by 2, count plus plus, and then I said, swap list sub count with list sub, and then I figured out, I did a mathematical expression to figure out what the number on the opposite end would be. Basically like num items minus count plus 1 or something like that. And swapped them. So that's actually what you'll see when I post the lecture notes. No, actually I did have a forward count and a backward count, but I didn't include the backward count in the for loop header. So anyway, you can take a look at this and then compare it to what you'll see in the lecture notes. Question? The prototypes? Okay. All right. So, question.
Is it possible to make it, instead of doing like the backward swap, like the swap algorithm, could you just make it an array and then just feed it in an array backwards and then assign that array as a new array?
You could. So the question is, couldn't you just declare, I think we're coming full circle here because I think this is where we started. Couldn't you just declare a second array, copy the items from the second array into the first array in the opposite order, and then when you were done, assign that original array back, assign the new array back to the original array. I think that's what you were asking, right? Yes, you could do that. You can't use assignment statements with arrays, so you'd have to actually have another loop that did that. And so actually that technique would be quite a bit less efficient. You'd have to have a whole nother array, and you'd have to go through it twice. But yeah, you could do that, and it wouldn't be a big deal if you did it that way. No, because you can't change the reference. There's no way to do that. No. Because in C++, an array name is a constant pointer, so you can't change what it's pointing at. Yeah.
Just declare, when you declare list, array size, in the main function, you don't have to say constant, and when you put the constant list in the void printf function, right up there in the declaration.
Okay, so here I'm declaring a list. Do I want to be able to change the list or not? Yes, I want to be able to change this list, so I do not put the word const.
Why do you want to be able to?
Well, because when I first declare it, it's got junk in it, and then I want to be able to actually put numbers in it that the user enters, and then I want to actually be able to move them around. Okay, so this is not a constant. It's a variable because it's going to change. Okay, but then down here in this function, I've got this variable named list, but I'm not going to change it. I'm also doing is printing it out. So I make it const.
But when you pull that in, that constant list, you can just say it's a constant variable now.
Yes. All right. I will see you guys next time.